you have a YouTube channel and you publish videos of your robot doing cool things. And that was back in the days over 10 years ago when a robot could climb stairs. You got immediately hundreds of thousands of views. We went to events. We'd love to show our robot off, right? That's what happened. And what happened is people would see it, and people from the innovation departments, really forward-leaning people, they did the connection, said, huh, interesting. Something that I observe is there's a lot of excitement in what we call building the shovel, right? It feels like, hey, there's a gold digger's time. There's something out there. Everybody knows it's coming. And a lot of people are trying to, we don't know how that's going to look like. It's too complicated to talk to customers and exactly figure out, but let us build the tech layer that we're sure eventually will find its way. We'll build the best tech.
We are live. Hi, Peter. Welcome on BitBuilders.
Hi, Gabriele. It's a great pleasure to be here. My name is Peter. I'm the co-founder and CEO of Anybotics. We're a global company, but we started at ETH Zurich, in Switzerland. We're a spin out. And what we do essentially is automating routine inspections in critical infrastructure. We build a four-legged robot that can move by itself, walk anywhere where people can walk. It's fully autonomous. So you install it one that it can do the job itself. And ultimately what it does, the robot collects data and it uses visual, thermocamera, acoustics. And we'll speak about it much more. But ultimately it's about, finding problems in critical processes in the industry to avoid downtime, which is very costly, but also keep people out of harm's way.
I want to understand something about you. How did you get into robotics? And then why quadrupeds? And is it something that you've started at ETH, or does your love with robotics, if you're in love with it, I mean, I don't know, right? You haven't told me. I think you might be. Does it go back, further than ETH? What's your background story? Where are you from? And, how did your background, lead you to build small robot dogs?
Sure. Well, big questions here. I'll keep it somewhat concise, but I'm certainly a robot nerd, but not for the robotics sake. I just love building things, right? Already as a kid, like many of us, building the Lego, Meccano, building, programming very early stage. But I also always love the creative aspect from design, from drawing, but photography, video, 3D animations, these kind of things. And it's always the interplay between technology and the creativity. And ultimately, I studied mechanical engineering. I already had a sense there during one of the visitation days at ETH Zurich. They actually had a little robot and a haptic device feedback. It was amazing. It was like, okay, that's it. Just for the sensation of seeing that machine, I want to understand how to do that. And from there, from my bachelor thesis to the master thesis, and eventually the PhD, always was focused on robotics. And why robotics? And there's many exciting other topics as well, but robotics is so brand new, meaning that you can be really creative. It's a blank slate. It's a white sheet of paper that you can, express yourself, come up with crazy ideas, and actually in quite short amount of time do something. And then, I built a lot of different robots, participated, worked on humanoids, flying robots, robot that would balance on one ball. So all these crazy ideas. And for me, it's that, journey over many, many years now, over 15 years in robotics, but it's still the same fascination for the technology, yes, but ultimately also what do you do with it, right? The impact you can have with your customers.
And I want to ask you, how did the first contacts with customers happen? So, I can imagine at some point you got this built from scratch robot to walk. Maybe it had some type of navigation systems that you could use. And then you had to find some type of application for it. How did that first customer discovery and use case discovery process happen to be?
Yeah, it actually, we were still students, right? And it wasn't that deliberate. What happened is you have a YouTube channel and you publish videos of your robot doing cool things. And that was back in the days over 10 years ago when a robot could climb stairs. You got immediately hundreds of thousands of views. We went to events. We'd love to show our robot off, right? That's what happened. And what happened is people would see it, and people from the innovation departments, really forward-leaning people, they did the connection, said, huh, interesting. And in our case, it was the large operators in oil and gas and other industries that said, hey, we're looking actually for a super mobile device that can move through our facilities. And they asked us, look, can we run a test with your robot? And we're like, why would you want to do that? Why don't you put sensors everywhere? Turns out you cannot put at every position a sensor, right? Like, okay, why don't you use humans? Why don't you use drones? And all of these questions. The more questions we asked, they had really good answers for it. And we're like, makes sense. Maybe we can indeed help them. And so this were the first contacts, very early phases. We participated in challenges that some of these companies organized, and then just kept exploring, putting out there what we had, and on the other side, see the resonance in the market. You won't be able to just invent the market, right? You have to really listen in between, and also be careful that one customer who says this is awesome is not a market, right? So also then seeing, hey, if we have this, does it financially make sense? Is the market big enough? And to then explore and see where's the strongest connection. There were also other ideas, right? We looked at last mile delivery. We looked at search and rescue, entertainment, so many things where you could use it for like a robot for. But ultimately for us, we settled on industrial inspection because technically it's feasible, because these are very controlled environments where, you don't have dogs and kids moving around. It's really, you can solve it today already, or even, a couple of years back. Plus, financially makes a big impact. Now, if you do last mile delivery, your unit economics is very, very challenging for a robotic system. In our facilities, right, our customers, they produce hundred thousands of dollars of revenue per day. If we can help them mitigate a few hours of downtime, reduce the exposure of people to hazardous situations, that's a big financial impact. So for us, it makes total sense to choose industrial inspection as a beachhead to really focus in the beginning on that topic.
Help me help me understand what exactly in industrial inspection is missing. Feel free to go deep. And as I told you at the beginning, lots of the people that listen to this are nerds and engineers, which I love. So what's wrong in that market? What's missing? And why four-legged robot is the best form factor to solve for it? Or, maybe in
Yeah.
what subset it is.
Yeah. So over the decades, right, the industry, and that's the industry 4.0 movement, started to automate more and more and more. And so you have the systems, the equipment itself often comes with sensors, right? And there's a whole range, as a market of IoT sensors, third-party equipment you can attach to the assets that you have. Ultimately, what is the industry doing, right? They're producing, they need to squeeze out the most revenue for their asset. They need to prolong the lifetime of it. And so automation makes complete sense. But you're going to start hitting a limit, because not for every problem that you have, you can attach a sensor. Also, these sensors become costly, right? They have a certain lifetime. Then you have communication. So the setup is very, very expensive. And so what happens is, for critical processes, safety critical or continuous control of the machines, you use built-in sensors and systems and sensors, and the DCS systems to control the environment, to control the process. Now, that's not enough. You also need to see in between the equipment. So, for example, if you have liquid leakages, coolings, or oil dripping out, these are early indicators of a problem. If you have hotspots in the environment, a machine on the outside, if you have vibrations is a big one, right? You have shaft misalignment, you have a ball bearing that's about to fit. These are all things that, if unit placed for every location, right, it's very difficult to find that problem. And so what happens is, it's a mix. The industry maximized on sensors until the ROI didn't work out. But nevertheless, with every shift, you had people that walked around to collect data. Now, collecting data is actually not that easy. Number one, our eyes and ears are not good sensors. So what you end up, you need subject matter experts walking around with thermal cameras and vibration sensors, etc., which is a profession by itself. And then it's very hard to find these people. Number one, they will maybe do it once a month, maybe once a week, so frequency is not high. The consistency is very difficult, and then you also have a delay in what they can deliver. And it's just hard to find the people ultimately. And so it makes sense to replicate that in a parts of what you cannot cover with sensors, plus what people do today, and automate that with a robot. And this is also the shift now, moving from the industry 4.0 to industry 5.0, where it's not about just completely automating everything, but combining what does a human do? And that's understanding contextually decision making based on data that such robot can bring. So for us, we'd rather have the people, the experts, focus on the analysis, contextual understanding, than the repetitive, often distant and dangerous work of the data collection, right? And so it's this collaboration between humans and robots that's the first time possible. And you ask about why four legs then? Okay, why don't you use drones or something else? The fact is, these industries are built for humans, right? It's full of steps and stairs, and these industries have grown historically. So it's not that, you can perfectly plan it in the beginning and make it robot friendly, but every week, every month, you have a construction site, it's expanded. Many of these facilities have been built 30 plus years ago and still need to live, 30 plus years. Even for greenfield facilities that are fresh built, it's actually cheaper, right, to save the space. Space is a luxury. So things tend to be stacked on top of each other, connected through stairs, confined spaces where you need to crawl through. And again, a four-legged robot here is ideal because you need to be able to climb, including stairs and steps. A drone is difficult to achieve that because of flight time, regulation, payload. You have a lot of sensors on the robot and just the autonomy in environments where you don't have any connectivity to the drone, right, or to the robot. So you also bring the compute and autonomy, the sensors, the lidars with you. And here it's quite complementary. Actually, four-legged robot carries the heavy sensors and does it routinely, multiple times a day, whereas a drone is typically a human-controlled device once a month, once a quarter, and to get a new perspectives into tanks or flying along scaffolding or other, getting a higher perspective than what a human or our robot in such case could do itself.
You have a robot that you can put on the ground, have it walk around. You can have it record all type of video data. You can have different sensors, multi-spatial if you want. If you want to put infrared, you probably can. I don't know if power requirements allow, but yeah, you're nodding.
Yes.
So I think they do. And it can look at things and it can see things. But what is the minimum level of technical requirement that you need for, if I were to start today, a quadruped company,
Yep.
do you need to have autonomy to navigate into mapped environments? Can I have planned motion? What do I need to have on the sensor side?
Wonderful question. And that's very, very important. And the use case, that's very, very important. Will be a longer answer and we'll have a discussion on it, but
Please.
that's core to how to bring a robot successful to market. Let me start. I mean, if you were to build just a quadruped robot by itself and send that into a facility and hope to find something, that's not going to work, right? You need to be very, very specific on what are you trying to solve? Is there even, what is the historic data shown you? What are the problems that this facility has suffered from? How do they show up on what equipment or what sensors do you need to look at? How often and what from what perspective to have a chance to find the problem? So at the center, actually, it's important to understand our customers, they're not in the business of buying a four-legged robot. They're in the business of optimizing the uptime. And so what they're interested in is information, insights that helps to take them good decisions, early decisions and precise decisions. And ultimately, our model as well, right? We learned that the robot is a core enabler, but at the center of our offering is actually the software, the AI that turns all this data into valuable information. Now imagine, and in the beginning, we delivered the raw data, the photos, the videos, the thermography, all the sensors you could. And by now we're collecting some 100,000 of autonomous inspection points per month to our customers. Nobody can look at that manually, right? Nobody has the time even. So what's clear to them, they said, look, all the data is valuable, but it will be archived. So we can go back and historic purpose. It's important to look over time. All the orange stuff, warnings, nah, we'll ignore. Show me the red stuff. Show me the real problems, right? And so there we're building this entire data set and training and AI capabilities such that the reliability engineer has a dashboard, a front end, a notification system, user management, and root cause analysis tools, multi-sensor overlay. So the full contextual understanding to see where the problems are flagged by the robot, but then dive deeper and ultimately support the decision to do something about it or warn somebody about a potential issue or take a decision on triggering a work order. Now, working our way back, we have the software. What do you need to collect the data? Certainly you need autonomy. Nobody wants a remote controlled robot. If you're there, then you could also just do it yourself, right? There is moments where the operator would love to, can log into the system and remote control it for situational awareness. But 95% of the times the robots are used, this is completely autonomous. And this is where the beauty of robotics and the promise of robotics comes in, right? You have a system that can do the same task over and over by itself repetitively and very precisely. Now, coming back one level even further, you need the quadruped robot. Yes, you need the platform that can actually carry the sensors. And here, the minimum, what we found is certainly visual, thermography, acoustics. These are the minimums: listening, touch, right of sense, and seeing. And then, of course, smelling, gas detection, and then also, and all of these things can also go beyond, right? The robot can smell gases that we don't. The robot can see temperatures that we don't. It can hear ultrasonic sounds that we don't. So it's going beyond actually what the humans can do. Then on the lowest level, you need a four-legged robot. And there, what you need is just a high performance of robot that can move through the entire facility, that has a small form factor, can carry enough payload, but is also ruggedized, right? You don't want to have a toy that, breaks if it rains or something, right? So you have a ruggedized industrial product that can take a beating in very dusty, wet, corrosive environments, reliable, lifetime for multiple years, easy to service as well, and then also very important safety and certification. Now you have the basics of the people certification, such as CE and FCC, but we're entering highly, hazardous environments where potentially explosive gases are. So you're not allowed to ignite a spark. And that's very difficult to achieve for a robot with batteries and motors, etc. So that's why we also built a second product line called Animal X, which you can send into explosive environments. But as you can tell already, this is a big stack of topics that you need to solve. And the four-legged robot is a key enabler, but ultimately the value comes from the higher level software that you provide.
What do you think is the key challenge for this form factor? Where does it fitness end essentially in these deployments and applications?
Yeah, the beauty of a four-legged robot is its versatility, right? With four legs, you can literally move anywhere that a person can go, right? Maybe some of the challenges are the viewpoint, right? Sometimes a human is higher than the robot. In those moments, actually, the robot can just step back a bit if there's space and use the zoom cameras with high resolution to do it. So we find in many, many cases that that's not a limiting factor. And with that versatility, but you also, it invites that the complexity of the robot is still with 12 motors and the payload, etc., is relatively high. So the ROI doesn't always work. If you have a very dense and large facility, it's perfectly fine. But if you have a smaller substations, a couple of meters where it's all flat, you don't need a four-legged robot, right? So what we're big believers actually in that there's no ultimate one form factor, not a four-legged robot, not a humanoid robot that will solve it all. But the beauty of it is actually that you can adapt these robots to the task at hand and optimize it. So instead of having a humanoid, cleaning your dishes, you have a dishwasher, right? So that's the analogy here. And so for us, we're also, we're not saying we're a four-legged robotics company. Our vision is actually creating a workforce of autonomous robots, but that workforce can come in different forms and shapes, right? And optimize to the task. So we can take our robot, but keep 90% of the modules, hardware and software, maybe just attach four wheels or tracks, whatever you need, or, magnetic wheels if you want to climb walls, but reusing a lot of the components. And that helps us to build an ecosystem while increasing step by step the value. Right now, we're very focused on four-legged robots, to not dilute our resources and efforts, but ultimately, I believe in a heterogeneous fleet of different type of robots.
Is it enough to build the three stacks that you explained me, or do you have to go further than that and then build also deployment motion that works when you can rely on partners?
Yes, I love that question as well. Touches on very, very important strategic questions that we took quite deliberately. And you're absolutely right. What I described is essentially the core product, the solution that we have, but that needs to come with a lot of additional layers and the integration of their and cybersecurity, warranty services, all of that topics. But let's focus on the integration part. And this is a key necessity, but also enabler and competitive differentiator ultimately. The reason, what we found in the beginning is we thought, hey, let's build a robot, and there's the big companies and resellers and others. They will figure out how to deploy these robots. So we don't need to reinvent here, our process. But it turns out, because this is such a new market, right? There's a few companies that do what we do, less than a handful, right? That this is pioneering work, and it's essentially not a product yet in the sense that people know how to use it. When you buy a car, it's very clear how to use it, right? But if you, just buy SAP, they don't, you just not just download it and start using it. It's much, much more complicated than that. And this is often currently the state with robotics as well, that you need to, even in the sales journey, but also then after the sales movement, you start building a deep relationship with a customer. And indeed, it starts very early on. What is a problem they're actually solving? How is it connected to the top line, to the return on investment? And then you break it down to individual assets, as I mentioned before, what are you expecting on, etc. Stakeholder management, the cybersecurity, the safety, all of that. People, there's entire groups and committees that need to decide, and you help the customer to navigate that. There's parts that we can do, parts that the customers can do. And so for us, we have, that was very early on, we understood that we cannot just ship a robot and wish the customer good luck, right? That won't work. Also, our customers, if you speak to them, they love that we're there with the people. There's a consistent contact from A to Z, somebody who takes care, somebody that takes responsibility, is there to set up the robot, but also understands, hey, where do we integrate it? Where does the data land? Let me talk to the reliability engineers. Let me talk to the operations teams. Then it's down to API integration, all of that. So it's a big, big project, but that's ultimately how you need to look at it. It's a solution that consists of a product, but also the entire go-to-market and customer success movement. And it's actually very exciting for us because we get to work hands-on with the customers. Our customer success team is quite sizable. I believe it's one of our superpowers at the company as well, to be out there to understand then the feedback and directly feed it back into the product. And that's a very nice reinforcement cycle. If you let that go in a market that is not fully established yet, right, it's going to be hard for you to keep competitive. So we see it as a necessity, but also as a beautiful opportunity for us to build that understanding.
You guys thought you needed X, but let's figure out together what you actually need. And you guys, thought you could achieve Y, but let's figure out what you can achieve and a timeline for that. Is that more or less the...
That's right. It's a very consultative sales process where the customer knows that the problems, that's what they're really good at, right? I mean, they know their facilities inside out, but they don't know what the robot can do. So for us, consulting, going deep into the problems, and we have by now, we're hiring, we have expert reliability engineers on our team that understand also the customer's reliability strategy and these kind of topics, but also understand the robot. So we're bridging that gap pre the sales, but then also after. We have a defined project where we agree on implementation milestones and KPIs we want to see from the robot. And that's a project we're going through together. And ultimately, this is also the trick from, instead of just deploying one or two robots to the customers for trial purposes, you have an entire scaling plan. 2 robots here, 2 robots over there. Once we have reached these milestones and KPIs, we're expanding, right? And that's the beauty. Our customers, they all have the potential for dozens, if not hundreds of robots. So for us, it means instead of diluting our efforts across many, many companies with one robot, we rather focus on some of the strong ones and the believers, and almost co-develop some of the solutions through that very close contact.
So what does a company like Anybotics that makes its own hardware and integrates it, what should you guys be aware of as you look at what's happening in this phenomenon? Where lie your strengths and where lie your weaknesses, essentially?
Yeah, no, that's a wonderful question. Certainly in the beginning, if I take you 10 years back, there was no ecosystem of robotic suppliers and parts. So we had to go really deep in and say, we need to build our own actuator because the ones from the industry are just not designed for lightweight robot. We had to build our own batteries, inspection panels, all these things that were just not around for a form factor. Now this has evolved, and absolutely there starts to be a commoditization of robotics hardware. But you can see this as a threat and say, hey, okay, we cannot do this business anymore. I see it actually as an opportunity, meaning that we can now stop doing everything ourselves that we needed originally, build some strong partnerships, and work with suppliers globally that have high quality components, including from Asia, and build on those. And then truly focus on what you're good at. So we're not a mass producer, low cost manufacturer, right? For this, clearly we'll need partners. We're neither a motor supplier nor battery. So things that are out there, if somebody else can do it, we should buy it, right? So that's the idea. What we're then really good at is still the robotics, the AI, the autonomy, those pieces and also safety relevant, right? Because that flows through the entire user experience up to the AI inspection capabilities. Because ultimately, a system that you use needs to be easy to use. It shouldn't feel like multiple systems glued on top of each other, but it's one cohesive, nice to use, nice, but also highly reliable and performant system. So yes, heavy focus on the software, but also on the system architecture ultimately. Now, yes, you could buy a four-legged robot, but that's just, as we mentioned before, that's just a carrier. We have great ideas already for the next generations of robots, how they will need to evolve to serve some of the topics you mentioned here before, to build an ever more specialized and performant data inspection vehicle, we call it then at that point. Maybe it's not even a robot anymore. It's just we're then used to that name. It's a system that can significantly collect high amounts of data. So yes, for us, it means use the opportunity, partner much more, including some of the, commoditized equipment, and with that, stay cost competitive. Yeah. And our power here is that, I mean, number one, we have a few hundred robots deployed already and growing, right, every week, meaning that we're very close to customers. We have the relationship. We start having the brand. We start having the data, and we have the critical insights. What is needed for the full solution? But then we need to, so we're taking ownership and we design the full stack, but it doesn't need to mean that we build the full stack. And wherever you can, find the right partners with, the specialized solutions, so you become yourself a little bit of a system integrator of different technologies to do that. But this is quite normal in all the tech industries, right? If you, from mobile phones to other devices, it's a play where you say what you want and you find the best and cheapest way to bring that together with global partners.
So, what is the case for building an OEM in 2025, essentially, where you're still building your own stuff rather than buying, fitting, coding on it, and then going and integrating it? Is it that the technology is still not there, so you need to build your own? Is it that you believe there's a longer lasting moat by building your own platforms? What is the mental model there?
Yeah. So we have to understand that the market is still in the early phases, that in for many, many years now, we'll see rapid, fast iterations. Right now, we're talking about four-legged robots. And a couple of years back, there was nothing around. Now we have a bunch of two-legged and four-legged systems that can walk. But that's just the early phase. And we'll look back in a couple of years and we'll be smiling how rudimentary that was. And right now, I think a specialization starts to happen where, depending on the customers and use case, you'll have your specific models. So for us, is not even an option to buy now off the shelf, robots, because we need to provide our customers a service at uptime. We need to show them that we're in control of the data, etc. So just putting things together is enough for a demo, but something that has performance guarantees, services, spare parts, apologies, security guarantees, all of that. Then certification, a big one, right? When you need to prove part of the software and hardware together, that today you cannot put together from individual components. And for us to serve the market, we need to do it ourselves. But you're right. What is the long-term play is for us to make sure that we're in end contact with the customers, but we're also in control of the edge. Now, the edge, I mean the robot itself. We need to determine what software runs in it and what third party and the communications, because this will then create this stickiness and the trust. You have something on the edge. It's like owning the phone, right? Apple and the other vendors, they take the profit here because they're in control of what happens on the device itself. Might be possible in the future that you're not making the biggest margin on the hardware itself, and that's okay, because then you have your value, the software and the capabilities that come on top of the system. And again, it comes to the very beginning when I said the customers are not here to buy a robot. That's just the entry ticket. Where does the value come from? And we're very clearly focused also on the value aspect, the growing use cases and inspection capabilities, but then also the software in the cloud and how you access an API. Yeah, I hope that gives you an answer how we think about that. The robot itself, what we're talking about, commoditization, is a part of the solution, but ultimately it's not going to be the cheapest or best robot or the cheapest or best AI model. It's who can package that in a solution that consistently and reliably delivers the value. This is how we look at it.
My take is what we're showing off today is what raises money. These very complex machines with, tendons to walk, like mechanical tendons to walk, and this very complicated and delicate bipedal motion, etc. All of this is what raises money. I think what's going to make money is this sort of like generalist two-armed torso on some mobile base that you can just drive around, have it do things without having to have security concerns of safety concerns of this very unstable, and we can dive into why it's unstable, robot that can fall on people. It's like 80 kilo of metal that, squishes you down. So I think in general, we'll have them in the future. It'll be cool to have them around, but most of the applications actually come from manipulation robots. It doesn't matter if they look like humanoids or not. They just manipulate things, right? I think at least that's my take. And so when I see a lot of the big raisers, right? So the companies that are raising multi-billion dollar rounds to build them, it scares me because it looks like capital allocation is going to a place where probably not all of the revenue will lie. And probably I'm wrong because, probably I'm wrong because that's going to trickle down in some form factor that's going to help these companies also make money. But I want to understand, what's your take here, right? And yeah, because that's mine.
I'm afraid we're a little bit too aligned. So for me, it's also the humanoid form factor. It's a manipulation device. And the biggest challenge today is not to build actually the humanoid itself, right? You see all these wonderful videos of backflipping, all the crazy stuff. That's fine. But what has not been solved yet is the fine manipulation, the end effector. So there's still ways to go, right, to reach that level of manipulation control. And they're absolutely right. These arms might be stationary or on a mobile platform, have 3 arms, 1 arm. So it's that has been, the need is unlocked. So it's clear that we need that, the flexibility thereof. But I also agree that they might not look like the human shaped with a head and 2 arms and 2 legs, because often it's not needed. So there will be a specialization. Nevertheless, I'm excited about humanoids and everything that's happening. Just imagine, 5 years back, we needed to explain to investors why robotics, right? Why is that a thing? Why is that even needed in the industry? And so that opened up a race, but also a general understanding that robotics is here to stay. It has a big impact. The race slash the form factor in the markets will evolve very quickly. And so I have nothing against humanoids. I also see there might be applications where it's completely feasible to say, I need 2 legs and 2 arms. Fine. But I do not think that humanoids will be the one robot that will, do it all. And this is also when you speak to humanoid companies, they see it the same way. There's all these still the questions about the fine manipulation, the safety you talked about. Then the cost will start to play a role. The exact use case they need to solve. So many of these humanoid companies will go through the same journey as many other robotics companies did. My concern is a bit, there's too many humanoids robotics companies out there right now. Many of them will not work out. So I don't want investors in general to be scared of robotics. It is a difficult topic. Takes more money, it takes more time than a usual SaaS company, a software company, but the opportunity is very exciting. So I'm thankful of the hype a bit, right? So it's good, but we need to be mindful to quickly deploy and show results and customer adoption. And this is what Anybotics has been doing for a couple of years now. And so we can position ourselves quite complementary to what's happening in the humanoid market.
I have another topic on the hype front, which I'm actually more excited about than humanoids, at least in the short term. I have just bought from an online store a Hugging Face robot. And just because I I was looking
Wonderful.
at too many people in my YouTube feed building it and teaching it to do things, and I wanted to try it. Right, I left my automation um, kind of efforts, a bit of university and automating some things in my parents' house, where I'm actually calling you right now from. And I want to get back into it. And the reason why I can do it without losing my job, for example, getting fired by spending too much time on it, is that it has evolved. An entire ecosystem has evolved where essentially I can take frontier end-to-end models, which I hope you will define for us, but that would be awesome. And I can just push them on a common hardware platform that it's somewhat well understood and well mapped. And then that hardware platform can do things for me on command. I can tell it to do things. And if the controls and navigation permit it, it will try to do these things. And it gets pre-trained on an immense amount of data, which is not, as big as we need it, but at least it's somewhat big. And it doesn't need perfect modeling of everything that's happening around it, which I want to put an asterisk in because I think it's a limitation. And then I can just do things with it, right? So I can tell the robot, hey, move my glass from the kitchen sink to the kitchen table. And if it has the capability to do it, if the glass isn't too heavy for it, it could do it. Like there's models today that do it. So I want to understand if you're excited about this, A, B, what the limitations you think are, and C, does it have anything useful for anybotics, this entire end-to-end models wave, or it's something for a different use case, a different customer segment, and just people like me buying a layer robot online.
So I mean, AI and robotics is a match made in heaven very clearly. And we saw this actually in 2019, where we already pioneered together with ETH Zurich. And just a small anecdote here for the technical people. It was, the time where it was all model-based control, the very, classical approaches. And that worked okay. It just needed a tremendous amount of engineering and debugging, and you always ended up at the limitation of human creativity and what you could note in mathematics and program. So it was a steady, slow progress. You would get somewhere. Especially Botramics has done a wonderful job over the decades that they have worked on this. But then I saw a demo of one of our students, a deep reinforcement learning algorithm. The robot was shaky and worked very poorly, but I just played around, and it was never trained to do that. But I ran it into a couch on purpose, just pushing the couch a bit. And in a traditional sense, for model predictive control with state estimation, etc., the robot would have freaked out. I would have been pretty sure. But that robot suddenly stopped with the front legs, kneeled down a bit in the front leg pushing, and the hind legs kind of like scratched off the surface and just recovered. It was like an animal, or if you're a human, pushes against a heavy object. I was like, wow, that's exactly, something has not been programmed to do, but it performs so gracefully. So that was for us a moment I said, okay, guys, we have to fully embrace this, right? We switched the entire team from the traditional approach at the company to do deep reinforcement learning. Within 6 months, we have models that worked really, really well. For the last 4+ years, we have been shipping all our robots with AI-based locomotion. And what I mean by that, and I'm sure there's different definition of end-to-end, but we use raw input from the cameras, from the encoders, from the IMU, and we spit out joint trajectories. So it's quite of a broad net. For us, autonomy is still a different layer, and we can talk about how to do the architecture, but that's certainly, it's, as I mentioned, AI and robotics is a match made in heaven. And for us, we're using that across the board. However, I'm not a believer that will be that one end-to-end model from raw data to the entire, everything that you do, including inspections. We're more, believers in a smart architecture, also for control purposes, for iteration speeds, etc. And what we have seen, the locomotion is pretty much solved by now. You can always optimize, but it's such a high performance and reliability that's great. So we can build the next level autonomy on. So we do obstacle detection, navigation, also now AI-based. And then, of course, everything you do in inspection is already AI-based, but different models for different use cases again. In between, there might be some traditional approaches, but if you have a flexible, smart architecture, this also allows you to do third-party models, right? If somebody has an amazing, detection of certain components or a new autonomy stack, we can very quickly integrate that into our architecture. And so for us, it just opens, it's a new tool that we're completely embracing, have been pioneering for many, many years. And I think the journey is on to do even more. You asked about where is this relevant for Anybotics? What I'd love to do is what you mentioned in the beginning. Right now it's still a robot that the human sets up. So we need to figure out together with the customer where the robot should go, where it should not go, what to look at. But imagine now with the hundreds of thousands of hours these robots have, spent at facilities. Think of them not as a, intern in the first day that you need to onboard, but think of it as an expert from the industry having spent hundreds of years. So this person, this robot could come in, walk one through your facility, and instead of you telling him what to do, he will tell you, these are the things I found, these are the equipment, these are typically prone to this error, and it will start having a dialogue with you. right? And so it's like ChatGPT co-solving the problem together. You're not bogged down by the nitty-gritty details on how to set it up, but rather on a very high level, determining together the strategy on how you're going to look at things, the historical data, what you already do, what you don't do, what the robot can do for you. I think there's a vast opportunity to build that higher level, not just autonomy, but true industrial intelligence engine for the robot to be an ever more performant coworker. That comes down to data. How much data can you actually collect, real world data from the facilities? And there, I believe we're very well equipped because you need to have the robots out there, right? So you won't be able to skip that by being a pure software company and simulating it. So I think that is an exciting field we're heavily investing in.
What you mentioned, it's more of a traditional deep learning. It's funny that we call it traditional right now. Traditional deep learning approach, and a lot of new transformer-based approaches with VLAs and kind of like these big visual language action models that are taking data that's coming from the internet to understand what's what, from text of the internet to understand what's my handler saying, as well as joint control. So data is coming actually from robots or from haptic sensors, wearables that people are using to collect data. All of this to spit out joint positions and torques. That's sketchier to me because like you don't know what's going on, and interpretability there, it's a big issue. So that's also what I want to try to talk to you about. Is that the step to get the generalized robot autonomy, or is more building it up block by block from a specific use case growing into a horizontal variety of use cases?
So for us, I mean, history will show, right? For us, it's the block by block approach. Yes, VLAs and other models on a high level for the highest level intelligence, very valuable. But at the same time, I'm very happy if we don't need to update our locomotion controller constantly, because also just builds the confidence to know if you commanded this, this will happen, right? The same thing. For us, it's still, as I mentioned, a new market. So consistency, reliability builds trust, and this is needed for adoption. So just going out and constantly with the craziest new AI models that you know what's happening, that's a risky business. So for us, block by block has been the successful trajectory because quite early on you can start just deploying robots successfully. If you're waiting to collect all that data to build this vast end-to-end model that you believe, I'm not sure if you ever you don't know how long it's going to take. So that's a bit of a dangerous trajectory. Meanwhile, though, yes, collecting data and systematic learning is key. And what you need to do that, you need a trust from the customers, you need all the cybersecurity in places, you need anonymization of data, you need to be in the front end of the customer. So if you just have a tech layer, you will never get the feedback if this data was good or bad. For us, it means we have the front end with the reliability engineers. They give us feedback. Was this correct? Was this wrong? And so with that, we're getting expert training over time. But you need to build it in your architecture together with the customer trust that you need to build, that you actually get hands on this very sensitive data.
You're saying I'd rather know what's happening inside my robot, essentially, at all times. And then as the stack evolves, you can probably add more and more features that can have that more of a one-shot, um, a one-shotting, trying to understand what to do next. But I want to be able to have the control layer at the bottom that I really trust, and I know I have, ruggedized and made reliable for myself. Is that pretty much the idea?
Yeah, that's the right philosophy, because the actions of your robots, especially the physical ones, they have safety implications. And for our robots are even part of our certification. So there's no room for error in that, right? Well, on a higher level for inspection capabilities, I'm happy to iterate quite quickly. And if maybe one of the interpretations is not perfect, there's still a human in the loop, and mistakes are okay for the sake of speed and iterations. Whereas on locomotion, as I mentioned, I'm happy if we don't need to touch that ever again, right? We'll still upgrade it, but the steps have become smaller because you also have a bunch of hundreds of robots out there. So whenever you touch it, you got to make sure that it's still working perfectly for all the existing customers, right? So the more physical, the more safety implications there are, the more testing you will have to do. And so iteration slows down as well, right? And performance expectations grow. So separating these two has allowed us to do still both be conservative, safe, but still iterate very quickly with the latest technologies and inspection capabilities.
One last question that I ask every guest at the end of every episode, which is, um, what is your advice today to people that are building hard things? And I think in this case, I think that the market is big enough and the interest is big enough that we can narrow it down to building robots and building robotics. What's your advice to these young people that are struggling to understand what to do next, what to focus on, what type of principles and guiding values they should have, especially with the entire, you know, commoditization fear that I think it's coming, at least in the niche environments and discussions. What should they? What do you think they should do and they should keep in mind as they move their first steps towards building robots for the next generation of hardware that's coming online?
Yeah, I mean, something that I observe is there's a lot of excitement in what we call building the shovel, right? It feels like, hey, there's a gold digger's time. There's something out there. Everybody knows it's coming. And a lot of people are trying to, we don't know how that's going to look like. It's too complicated to talk to customers and exactly figure out. But let us build the tech layer that we're sure eventually will find its way. We'll build the best tech. But that's very, very dangerous, right? There's more robotics tech companies. There's more fleet management software out there than there are actually robotics companies who actually do it, right? That's crazy. And so here I would embrace the actual state of robotics and take one customer problem that is big enough, but walk in the shoes of the customers, truly understand it, do it yourself, right? And then reverse engineer the problem and build your robot to do that. It's we also came out with a technology push, but I think what we did well is from the beginning say, hey, we need to be out there. We cannot just do research. So I myself, I spent, weeks and months with customers. I stopped programming the moment I graduated and built up the business development, marketing, the sales, etc. You need to have that deep understanding and build that market. I think that's very exciting. Not only fall in love with your product, that's okay, but also fall in love with the customer's perspective. And marrying these two things together is very, very rewarding. And it's one of the unique opportunities, right? If you're working in automotive these days, I believe it's pretty clear what a car does. But for robots, you can be very, very creative and still build the fascination, the positioning of how people will think and use, and yeah, interact with robots. And somebody's creative and has the energy for it, I would clearly advise in that direction.
I love it. Peter, I think this will be very valuable, and I thank you for all the time you put into this. I hope we can do a part two soon. And actually, I already made you promise that if I come by around your HQ, I can get a tour. Is that still valid?
100%. You're very welcome here and very happy to do a part two. This has been a fascinating discussion. Thanks a lot, Gabriele.
I love it. Thanks, Peter.
Thanks.